going to work backwards given our zeros and being told the information that we need about our zeros, like multiplicity, etc. So we're going to do just the algebra for this. Now, writing an equation of least degree for a polynomial, these are possible polynomials. We could expand these, but here's what we know. We know that, for example, on the first one, you have 3 x-intercepts. So it's going to be degree 3 when all is said and done. You know that one of them has multiplicity because we literally see the number 1 written twice. So here's what you need to recognize. If you're told that your zeros are 1, 1, and 2, just like we've been doing in the previous video, writing the factor it came from is going to be pretty easy. So if x equals 1, it must have come from x minus 1. Now, you've gotten that twice, so you can either tell me that it's x minus 1 squared, or you can go ahead and just write out x minus 1 2 times. It's not going to matter. You're still going to have to FOIL that out to get your polynomial. So x equals 2 is your third x-intercept, your third zero, so it came from x minus 2. This is all well and good, and if I had told you that you didn't have to FOIL, then you could have stopped right there. But when I ask you to go ahead and write out the whole equation, you're going to have to FOIL. So let's do that. I'm going to start with x minus 1 times x minus 1. So we have x squared minus 1x minus 1x plus 1. We clean that up. And we have x squared minus 2x plus 1. We drop down x minus 2. And we just big FOIL. So we distribute our x all the way through. And we have x cubed minus 2x squared plus x. We distribute the negative 2 all the way through. And we have another negative 2x squared plus 4x and minus 2. Remember that you have to simply combine like terms. So your final answer will be x cubed minus 4x squared plus 5x minus 2. Take the 0, put it back where it came from as a factor, and big FOIL. That's it. Now, it's going to get a little bit more complicated, so I guess really I should say that was it for that example. We got 2 examples left. Shouldn't be terrible. Okay, here we go. If it gets a little more complicated, I think what would be really beneficial to do here is to kind of refresh your mind as to a little bit of something from our past. And then we're going to basically model that and reverse it. So let's look at example 2. Off to the side, I want you to write this down. I want you to pay attention to what's going on. If you were in Unit 5, if we were in Unit 5, which was solving quadratics, we solve quadratics by complete the square, by quad formula, by factoring, by finding square roots, aka SADMEP. We've done it all. So let's refresh a portion of the complete the square process, which really is just SADMEP. So let's say I gave you x minus 2 squared, and that equals 5. Even more, even if I had minus 5 equals 0 instead. So x minus 2 squared minus 5 equals 0. If you're going to SADMEP this, you're first going to have to add the 5 over, the addition you can currently access, which leads you to x minus 2 squared equals 5. the next step that you would have would be to square root both sides. So you end up with x minus 2 equals plus or minus root 5. Last, you would simply take the negative 2 with the x, and you'd add it to the other side, putting it in front of the plus or minus, because protocol says to put it in front. So you end up with x equals 2 plus or minus the square root of 5. Okay, that's exactly what we're going to undo. So if I'm telling you in example 2, I'm asking you to write the equation of least degree. It's just a fancy way to say write it from what you're given. Just do your best you can with what you've got for a polynomial that has zeros at 2 plus or minus root 5. So x equals 2 plus or minus the square root of 5. For 1, notice that you have 2 zeros there because plus or minus separates those. That's 2 plus root 5 and 2 minus root 5, two very different numbers. Now they're written as 1 because you can work with them easily. In fact, we're going to keep them that way because it's really a lot faster. Okay, so all we're going to do is we're going to work it backwards. If the last thing that we did was move the 2 over when we were solving by SADMAP, the first thing we're going to do is we're going to put the 2 back. So I'm going to subtract 2 from both sides. So x minus 2 equals plus or minus the square root of 5. On the next step, we square rooted both sides. So if we're going to undo that, what we need to do is we need to square both sides. That's what's going to get rid of the square root, and consequently, that's what's also going to get rid of the plus or minus. If you square a positive number, it's still positive because you're multiplying a positive times itself. If you square a negative number, it's also positive because a negative times a negative turns into a positive. So this is actually a non-issue. And then of course, if you square square root, it's like they just cancel. So what you're left with is just 5. Now, on the left-hand side, you have x minus 2 squared. So you're actually going to do your due diligence, and you're going to write it twice and FOIL it. So you've got something that's actually of worth, in this case, a polynomial. We kind of need to have it FOILed out. So we have on the left-hand side, x squared minus 2x and minus 2x makes minus 4x. And then, of course, plus 4. So the last step would be to get 0 back on one side. So you can get everything together, so there's your polynomial. So what we did is we added 5 in the beginning. So now we're going to subtract it. We're going to undo it. So we're just going to move that 5 over by minus 5 on both sides, making your final answer, your final polynomial, x squared minus 4x minus 1. Believe it or not, if you were to graph this function in the calculator, you would see x-intercepts at whatever decimals 2 plus the square root of 5 and 2 minus the square root of 5 represent. So, one more. We just did when things were beautiful, when they were pretty, 1, 1, and 2, first example. When they were irrational, not quite as pretty, decimals and whatnot, as 2 plus or minus square root of 5. And now we're going to deal with what's imaginary. So thankfully, it's the exact same process as what to do with whenever it's irrational, when it's the decimals and the square roots and whatnot. So here we go. Your x-intercepts. We're eventually going to have a final answer. We'll deal with that whenever we get there. You have 3 x-intercepts. One of your x-intercepts is at positive 1. This is the easy one. It must have come from x minus 1. Your other two x-intercepts are at negative 2 plus 5i and negative 2 minus 5i. So we've got to undo that business right there. Same process you just did. We're going to start by moving away the negative 2, so we're going to add 2. So x plus 2 equals plus or minus 5i. It might sound absolutely crazy, but it's the same process you just did. Why? Well, last time we got rid of the square root by squaring. This is an imaginary number. Remember, an imaginary number is a square root. It's the square root of negative 1. So what we're going to do is we're going to square it. Don't forget, when you square I, it is negative 1. Let's have that flood back in from Unit 5. Just as an out there, because I haven't said it yet in the video, math builds. All right, so we're going to square both sides. Gotta keep it balanced. So on the left side, we take an easy x plus 2 times x plus 2, and we FOIL it out. X squared plus 2x plus 2x plus 4. So we actually have x squared plus 4x plus 4 on the left-hand side. On the right-hand side, a positive and a negative squared don't do anything. They actually vanish. Remember, positive squared are still positives. Negative squared are also positives. Negative times a negative is a positive. So that's a non-issue. So really all you got to worry about is the 5 squared, which is 25, and the I squared, which is negative 1. So if 5i squared is really 25 times I squared, that's 25 times negative 1, that's negative 25. So then all you have to do is move the 25 over. So let's make sure this is abundantly clear. You have your original x minus 1. And now you take x squared plus 4x plus 29, x squared plus 4x plus 29, and you big FOIL that with that x minus 1. Let's do that quickly. So we've got x cubed plus 4x squared plus 29x minus x squared minus 4x minus 29. Our final answer for our polynomial from working backwards with x-intercepts at 1 and negative 2 plus or minus 5i is x cubed plus 3x squared plus 25x minus 29. Now, one last word of caution. If you are given a fraction, it did not come from x equals that fraction. I want you to think this through. On number 2, on page, 23, the practice problems, we actually have a situation where x equals a fraction. X equals negative 1/2. It did not come from x plus 1/2. Think about what you would have done to get there in the first place. You'd have had to have moved over the 1 and divided by 2. So to undo it, you'd have to multiply by 2 first. So 2x equals negative 1. And then you'd have to move the 1 back over. So the factor that x equals negative 1/2 came from is actually 2x plus 1. So if I were doing number 2, I would big FOIL, I'm not going to take time to do that, I would big FOIL x minus 7 times x minus 4 times 2x plus 1, because that's how I got each of those x-intercepts. So here on number 6, if x equals 2/5 x, I'm sorry, not 2/5 x, just x equals 2/5, then to undo this, I would first need to multiply by 5. So 5x equals 2. And then subtract the 2. So the factor 2/5 came from was 5x minus 2 in a parentheses. Now for time's sake, I'm not going to bother finishing that one up. Just wanted to make sure you knew where the fractions come from. Okay, hopefully that wasn't too terrible. Thanks for sticking around.